Now we're going to do question 2. 2.1, we are given the following sequence. We are not told what type of sequence this is, whether it's arithmetic or geometric. But in 2.1.1, we are asked to write the next term of the sequence, right? So what we can detect, you can first try and finding the difference of these sequence and see if you will get a common number, but you definitely won't. So what I can notice from this sequence is if you have 9, how do you find 9? 9 is 3 to the power of 2, right? Or express 9 in terms of 3. Let me just say that. It's 3 to the power of 2. And how do you express 27? It's 3 to the power of 3. Express this 81, it's 3 to the power of 4. Express this one here, it's 3 to the power of 5, right? So if you can see here, we're having an exponential form of 3. So it's 3 to the power of 2 to the power of 3, 3 to the power of 4, 3 to the power of 5. This gives me a hint that this might just be a geometric sequence, right? So for us to prove that, because we firstly don't need to prove it, we just need to write the following term, right? So basically what's common here, what's common is 3, right? 3 is common, so basically it's 3. Maybe you just need to note the power. If you check, it's to the power of 5 here, it's to the power of 4 here, it's to the power of 3, to the power of 2. Definitely yes, it has to be to the power of 1. So this is our next term for 2.1.1. It is 3 to the power of 1, right? And then looking at 2.1.2, they say, does the series converge? Okay, so we know very well that convergence only happens in geometric sequence, right? What do I mean by that? We have an equation that says r must lie between 1 and negative 1. So this equation here, it actually explains the convergence of a sequence. So if and only if r lies between -1 and 1. So let's first find r, then we'll conclude on whether or not the series converges. So r is equals to term 2 over term 1 is equals to term 3 over term 2. So what is term 2? This is term 2, this is term 1. So term 2 is 81 divided by term 1, which is 243, equals to term number 3 is 27 divided by 81, which is term number 2, right? So you should find r to be 1 over 3 if you punch your calculator. So this is the value of r. I mean, this 1 over 3 is 0.333, which definitely tells us that it lies between -1 and 1. So you can conclude by saying 1 over 3 lies between -1 and 1. So this can be your final solution of this problem here. We're going to do 2.1.3. We are asked to prove that the general term of the sequence is equals to this here, right? So let's find the general term of the sequence. So how do you find the general term of a geometric sequence? We know it's Tn is equals to ar to the power n minus 1, right? Our a value is our first term, which is 243. It's this one here. And then our r, we calculated it in the previous question to be 1 over 3. So we're just going to substitute that. Tn is equals to 243 into 1 over 3 to the power of n minus 1. Remember about the 243. In the previous question, the 2.1.1, I said this is 3 to the power of 2, this is 3 to the power of 3, this is 3 to the power of 4, and this is 3 to the power of 5, right? So we can simply write that in terms of 3 to the power of 5, then into 1 over 3, all to the power of n minus 1, right? Then now we need to simplify this problem here. So for us to simplify it so that it looks exactly the same as this here, we're going to say 3 to the power of 5 into So we're going to write this in exponential form. So it's going to be 3 to the power of minus 1 to the power of n minus 1. So this n minus 1 will multiply any power that it finds inside. So it's going to be 3. So this is Tn equals to Tn. So it's going to be 3 to the power of 5 multiplied by, so this minus 1 multiplied the n is going to be 3 to the power of minus n multiplied by this minus 1 again will multiply the negative 1. It's going to be 3 to the power of 1, right? So we're going to add the exponents of these two terms here. So it's going to be Tn is equals to, so base 3, they have the same base, but the exponent is 5 and 1 here. So you're going to add both of them. It's going to give you 3 to the power of 6 multiplied by 3 to the power of minus n, right? Then we can simply write this as 3, which is the common base, and then we add the exponents, right? So it's going to be 6 minus n. So Tn, this Tn is now the same as this one here. Now in 2.1.4 we are asked to find the sum to infinity. So the formula for sum to infinity is a over 1 minus r, right? Of which our a value is 2, 4, 3, right? And our r is 1 over 3. So all these values, this one is just this one here, and this one we calculated it in previous questions. So we're just going to substitute that. So it's going to be 243 divided by 1 minus 1 over 3. So you're just going to punch that in your calculator to find the solution, which would be 364.5. So this is your solution of the sum to infinity. So now we're going to do 2.2. They say in the diagram below is a graph of some of the terms of an arithmetic sequence. The graph indicates that term number 8 is equals to 24. Let's look at the graph. Term number 8 is this one here. So if you go straight and this point, you get number 24, exactly what they said here, right? Exactly this. So term number 8 is equals to 24, right? And now in 2.2.1 we are asked to determine the constant difference for this sequence. So if you take a look, we're having a sequence here. Term number 5 is equals to 12, term number 6 is equals to 16, term number 7 is 20, term number 8 is 24, term number 9 is 28, and term number 10 is 32, sorry. So we can use any term here to find this constant difference, right? Because we know the difference between these two terms is actually the same, right? So the constant difference that I'm going to use here to find this. So you can note, if you take a look, term number 5 is equals to 12. Term number 6 is equals to 16, right? I'm just looking here and here. Term number 7 is equals to 20. Term number 7 is 20. So just by looking at these sequence 12, 16, and 20, the difference between these sequence is what? It's 4, right? 16 minus 12 is 4, 20 minus 16 is 4. So you can conclude by saying the constant difference of this question here is just going to be 4. So this is the constant difference that they're looking for. So now we're going to go to 2.2.2. They say calculate what term in this sequence will be equals to this number here, 124. So I want to know the term. So basically you're going to use the equation of Tn is equals to a plus into n minus 1d, right? Of which now we don't know the first term, right? But we know the difference. We know that d is equals to 4, and to find the difference we can use any term. We were told that term number 8 is equals to 24, right? Of which term number 8 is equals to a plus 7d is equals to 24, right? And to find the value of a, we're going to say a plus 7, our d is 4, equals to 24. And then we transpose this. So we're going to transpose this to the other side. We have a is equals to 24 minus 7 multiplied by 4. And then we find the solution of this. And then we find that our a value is equals to minus 4. So this is our solution of a, right? So now that we found our a value to be 4, it's going to be simpler for us to answer the question. So we're having our a value being equals to minus 4, we're having our d value being equals to 4, and our tn is equals to a plus into n minus 1d, right? And we are asked to find the term such that it's equals to 124. So tn is equals to 124, so meaning we're going to say 124 is equals to our a value, which is minus 4, plus into n minus 1, our d value is equals to 4. So you're going to say 124, and then you transpose the minus 4 to the other side. We have plus 4 is equals to the 4 multiplied by the n is 4n. 4 multiplied by negative 1 is minus 4, right? So when you add these two, you're going to get 128. And then you take the minus 4 to the other side. We have plus 4 equals to 4n. And then here it's going to be 132 is equals to 4n. And then you divide by 4 both sides, so your n value is equals to 33. So this is the solution of n required for 2.2. In 2.3, we are given this sum here, right? And 2.3.1, we are asked to find the sum of 4 terms, right? S4. So we're going to simply substitute that, because we are given Sn being equals to 5 into 1 minus 3 to the power of n divided by minus 2. So S4 is equals to, so this is 5, just so you know. So it's going to be 5 into 1 minus 3 to the power of 4. And then we divide by minus 2. So if you punch your calculator, you should get 200. So S4 is equals to 200. In 2.3.2, we are asked to calculate T5. So T5 is equals to the sum of 5 terms minus the sum of 4 terms. Remember that S4 is equals to 200, which is what we calculated in the previous question. So now we just want S of 5, which is equal to, so we're going to substitute it in this equation here. So it's going to be 5 into 1 minus 3 to the power of 5 divided by minus 2, right? And then your calculator will give you 605. So this would be your answer. So term number 5 is equals to S5 minus S4 equals to S5 being equals to 605 minus 200. And the answer you need to get is 405. So term number 5 rather, is equals to 405.